Hello, everyone. I'm Sharik Pahwa, Technical Account Manager in AWS. And alongside me is Nikos, all the way from Macedonia from Sharethrough. Today, we are going to discuss about Sharethrough's adoption of AWS ECS Capacity Provider and how they were able to accomplish better performance and efficiency than their existing vendor solution, where they were up till last year. So before we go dive deep more into it, let's just understand more about what Sharethrough is. So maybe you have a next slide. So yeah, what is Sharethrough? Sharethrough is pretty much an ad exchange. Next slide actually. Sharethrough is an ad exchange which connects publishers to advertisers via demand side platforms or supply side platforms. What we normally say is DSPs and SSPs. Uh, and pretty much across all the default demand types, which is display, native, and videos. Now, giving an idea about the scale of Sharethrough. Sharethrough operates at around 2 million QPS, which is quite a big number. They are across 4 regions, 3 continents. These are AWS regions, by the way. They have been AWS partners since 2011, and they do cater to 200 plus countries. Now, with this scale, definitely needs a lot of compute to manage this. So as Sharethrough has its app stack already containerized, they leverage AWS ECS. And with this AWS ECS orchestration, I mean, EC2 Spot by default becomes the default one of the smart choice or preferred option because of its cost benefits. And that's exactly where Sharethrough was leveraging a vendor solution to provide them with a better availability of Spot instances. At this point, I'll pass over to Nikos to walk us through how Sharethrough was able to leverage a native ECS offering uh, without compromising on availability and performance and get out of a vendor solution to a default AWS ECS solution. Nikos, over to you.
Thank you, Sharik. Hi all. I'm Nikos, as Sharik said, coming to you over from all the way from North Macedonia in Europe. I've been maintaining Sharethrough's infrastructure for about 6 years now, uh, going through multiple iterations of the exchange infrastructure and architecture. But it's safe to say that almost all of them included the use of Spot instances, and anyone that has used them, especially in production, can tell you that even though it may not be an easy task, it's necessary because of the great benefit of reducing costs. So every iteration of the platform actually included Spot instances, but as of like until last year, we have been using a third-party solution that we have been utilizing for several years. Can you please go back one slide? Thank you. Okay. So this was a solution that was pretty much exceptional. It integrated seamlessly with our ECS clusters, provided the deployment of Spot instances whenever necessary, and most of all, a smooth and effortless transitions from spot to on-demand in periods of spot market. Again, anyone that has used spot instances will probably know what spot markets are and how they can hurt you on those bad days where you just cannot procure a spot instance, and especially when using this in a production environment. So just to be clear, this solution was great and it was working seamlessly. We did not have any issues with it. So next slide, please. So in that case, the question becomes apparent, why did we move out? And as anyone handling the throughput that we have handled will tell you, it was related to cost. Next slide, please. So this solution was employing a billing structure that was aligned with a pay-as-you-go model. It did have multiple options, and of course, there are other similar solutions out there, but it always came down to a fee equivalent to around 20% of the cost savings, which with the enormous growth of the exchange become more and more unbearable, especially to the business side of things. So we identified that if we find a way to transition away, it would have the potential to yield us annual cost savings of up to $1 million. Now, keep in mind, these numbers are last year's numbers, and the exchange has grown a bit more since then. So it's even more savings today. Next slide, please. So, how did AWS ECS Capacity Provider benefit us? So, while it's next slide, please. So AWS, unlike the third-party solution, will exclusively bill you for your utilized instances, be they spot or on demand. So it will not add any additional cost for running your ASG infrastructure or ECS infrastructure, and of course there will be no any charges related to your accrued savings. So this achieved us with approximately 80,000 reduction. Again, last year numbers, so this is even more as the exchange has grown significantly. And one added benefit that we were not even looking for, but we did get because of the way that ASG works and leveraging ASG with ECS, both in-house AWS services has reduced the instance provisioning time for us from 5 to just 3 minutes. While it not may seem like much, running like anywhere from 15 to 2000 instances, it does help you get quicker scaling and save some more money too. So establishing the ASG infrastructure itself was relatively straightforward process. ASG has multiple features that AWS has been adding through the years, and I can say from comparing the third-party solution in par with ASG, they did get very far, and there's almost every feature was available. So this was a straightforward process. Next slide, please. So one thing that this process did not have was, and something we took for granted, was handling the fallback from spot to on demand on those bad spot market days. This was just a box that we would check with the third party provider, and it was just there. So and this is just not something that AWS has. So for ASG capacity provider to be able to do this, you could leverage multiple capacity providers in one ECS service. You just have to leverage weights on them. So let's say you run 100% through the spot one, and then something happens, you cannot procure a spot instance, you need to switch to the on-demand. Switching weights for the capacity providers would trigger a deployment on said ECS service. And in a dynamic environment where our teams are already deploying multiple times a day, this was just not acceptable. So we needed a solution to handle this. Next slide, please. So what we did was we engineered a Lambda that would actually take care of that for us by implementing two discrete capacity providers, one for spot and one for on demand, where our goal is to have the spot capacity provider be the one that listens to ECS requests for tasks and handle those, ideally running 100% of them, and then the on-demand capacity provider, which would only be related to the same ECS task and service, sitting idle at zero, not really caring what ECS needs at the moment. So then with the help of the Lambda and some CloudWatch alarms that you'll see later on, we facilitate an automatic transition from the spot-based auto-scaling group to the on-demand one. This would happen in case the spot capacity provider was not able to spin up instances. It would trigger an alert, and then we would run instances in the on-demand capacity provider in order to satisfy the capacity that ECS needs. And then after doing that, we implemented a gradual reversion process to the spot instances, which you'll see in the next slide. So our goal here was aiming to always run on spot instances while having an uninterrupted service, optimizing cost efficiency without compromising the performance. Next slide, please. So the way we did it here is that it's the little diagram. I don't know how much it can be seen from there, but the flow would actually be like, let's say we're running 100% on spot instances. And then we notice that for 20 plus minutes with a CloudWatch alarm, of course, the spot capacity provider is not able to satisfy ECS desired count. So as long as desired count is more than the running count, that alarm triggers. essentially triggering the lambda. And then the lambda will calculate the delta between the desired and running count, and it would spin up enough on-demand instances that will automatically attach to the ECS cluster and service, providing the needed capacity to the service. And then that immediately will scale down the spot service so that it's running as much as we need. And then that subsequently triggers a second alarm. The second alarm is essentially a force push that we do on the spot capacity provider, that so that it continuously tries to rerun those instances that it cannot run. So as long as the problem persists, we will be stuck in a loop and until spot instances become available again. So we will have the sufficient capacity, but also try to run spot as much as we can. And this is what the second alarm will do. And then as long as we are running more than zero for the on-demand capacity provider, what we do is we re-trigger and remove an X amount of instances. In our case, we've tried with 2, with 5, with 10. It doesn't matter, whatever works for you. But each iteration, we try to run the missing instances on the spot capacity provider. If that succeeds, we remove them from the on-demand and satisfy the spot until we get the on-demand to zero, achieving victory as we've cleverly shown there. So, and then that triggers the alarm, and this is a continuous loop that we do have on the Lambda running for us at multiple times. And we have been running this for more than 9 months now. We've yet to encounter any issues with it, and it has saved significantly. Next slide, please. So this is just our architecture showing what I was just talking about. So we are running currently behind an NLB, and the network load balancer imposed an additional limitation unrelated to running ASG or capacity providers, which was could not run more than 1,000 tasks behind an NLB target group. This is something we had to find a workaround for, which we found by splitting the solution into a per AZ setup. What you see here is each of the availability zones has its own spot and on-demand capacity provider, which is on the left side. And then the right side, I just didn't want to replicate it 5 times, but this is what each of the AZs have. And what I was just talking about is presented here. So the spot ASG, when unable to run enough and sufficient spot instances, it would trigger the alarm, and the SNS would trigger the Lambda, and the Lambda would just run the Delta, and then the other alarm gets triggered, trying to push everything back to its natural state, which would be running 100% of everything through the spot capacity provider. So until we're satisfied, this happens. And in addition to that, we've added notifications on Slack, which aren't shown anywhere here, but I can assume everyone has that and it does that on some level. So what we do there is we get notified every time we get a transition, and we get notified on how many how many on-demand instances we are running, and whether we are in our clear natural state. Next slide, please. So what I've shown so far is the solution as we built it initially, and we have ran it for at least a month without any issues, and I'm happy to save some money. But we have realized one thing, and this is we use a large variety of instance types, which is as shown here from a 2x to a 32x large, which enables us to take full advantage of the spot market the more instance type you use. And on top of that, what's not shown here is that we leverage compute, general memory, also Graviton instances, which allows us to run, I think, somewhere more than 140 different instance types and sizes. So what we do is on larger instances, we run multiple tasks. So for us, one task is the equivalent of a 2x large instance. So on a 4x large, we would run 2 tasks, etc. And as I said before, ASG has a lot of options to use a variation of strategies for spot instance allocation and placement, and that all works perfectly. But one thing we did find out it lacks is the ability to recognize that we are running multiple of the same tasks on the same instance, which for us translated to the cheapest recommended instance always being the smallest. just because a 2x large is always cheaper than a 4x large, but a 4x large is not necessarily double the price of a 2x large, which for us meant that the price per core or the price per task wasn't really getting translated as needed. So we weren't saving as much as we could. What we did with this second Lambda is this is a scheduled Lambda that we run once a day, but again, to each his own, you can run it as much as you can and want to, but the Lambda will fetch the daily spot prices for all of our used instance types. It will calculate what our cheapest price per core or price per task is, and then do a prioritized list based on that, where the cheapest option would be on top, and then just descending below with the whole instance type list. And then it would update the ASG with the use of the prioritized allocation strategy, another neat feature that ASG has. And what this did is will improve upon an already efficient solution to help us save even more money and still stay stable and keep the service running nice and neat in all cases. And what we've experienced is, again, I'm going to go back to spot markets. Like spot markets, especially when using spot instances in production, spot markets are really bad around the holidays. And being in 4 regions throughout the world, there's always holidays, and when there's holidays, people are doing more and traffic is getting higher. Even on those days, we haven't really experienced. I would say I've never seen us run more than like 50 to 60 on-demand instances. One thing that I gotta say, I was never gonna say a bad thing about the third-party solution. It was working, but we did notice a slight difference in us being able to procure spot instances with purely ASG versus running the third-party solution, which is another added benefit that we weren't looking for. And with that, I think I'm going to wrap it up and open it up to any questions you might have. Thank you for sticking with me. And Sharik.
Great. And then for anyone who's online, if you just want to raise your hand, we'll call on you. And then anyone local, run the microphone back and forth if you have questions.
And I could comment that one. So a lot of information here. We have principal times and times here. We have networking time. If you have questions on that one, you can ask questions there as well.
Yeah, once you mentioned that, one thing I did fail to mention is that throughout like every iteration of our infrastructure, but especially with this one, Sharik and the whole TAMS team and every AWS supporting team has been guiding us and helping us identify the specific parameters we need. So I would say kudos on everyone that was involved to that, and we really appreciate it.
Thank you.
Yeah, glad to hear it. Quick poll of the room. Any questions? Anyone online? Okay. No problem. I guess we'll get some more time for the next meeting. Sharik and Nikos, thank you so much for joining and presenting.